Once they could see their opponent's face. Now they fight dozens of miles apart. Once they were inexperienced pilots in fragile planes. Now, $1 million of training and a multi-million-dollar weapon. No form of combat has come so far, so fast. In World War I, a new kind of combatant appeared. The fighter pilot. He was glorified as a knight of the sky, freed from the horrors of trench warfare. But the truth was darker. The pilots were armed but unprotected. The parachute still lay in the future, so they had no way to escape a burning aircraft. To fly the planes took skill. To get in them took guts. Maneuverability was key, and no plane maneuvered like the Fokker DR-1 triplane. The Fokker was the weapon of Germany's top ace, the Red Baron. It had short, stubby wings to make it more maneuverable. But this advantage had a drawback. Its radial engine spun along with the propeller to keep cool. These spinning forces, called torque, made the plane hard to control. In the hands of an ace, it was unbeatable, but many pilots found it more than they could handle. In the decade since World War I, fighters became larger and faster, but less agile. Then came the 70s and breakthroughs in computers and electronics. Like the Fokker triplane, these designs were aerodynamically unstable. But unlike the Fokker, they were safer and easier to fly, thanks to computerized controls called fly-by-wire. With conventional controls, a pilot can't possibly make all the minute adjustments to keep the plane stable during high-speed maneuvers. But the computer can be programmed to do it for him. Result: unparalleled maneuverability and safety. With a World War I biplane, the pilot struggled just to stay in the air. In modern fighters, the machine responds to the flick of a wrist. The first weapon of the fighter plane was the machine gun. On World War I fighters, guns were mounted on the fuselage because the wings were too fragile. The trick was not shooting off the propeller. The critical innovation, an interrupter gear. This device was linked from the engine to the machine guns. It interrupted fire when the propeller was in front of the barrels. When the blades were clear, the guns fired. World War II fighters were built mostly of aluminum. Their wings were sturdier than those of the biplanes. They mounted 4 to 8 heavy machine guns, much more firepower than the fighters of World War I. As jet engines increased speed, machine guns couldn't keep up. Missiles have replaced guns as the weapon of choice. The first practical dogfighting missiles used infrared guidance. A small seeker in the nose seeks radiated heat from an enemy aircraft. This is how a fighter looks to the human eye. But the missile sees only infrared energy. Early infrared missiles could detect only the jet exhaust. So a pilot had to maneuver behind an opponent to fire. But advanced sensors allow missiles like the AIM-9M Sidewinder to detect smaller amounts of infrared energy. During high-speed flight, friction with the air causes heat to build up on a jet's forward surfaces. The Sidewinder detects this heat so it can be fired from any angle, even head-on. The latest version of the Sidewinder is the AIM-9X. With thrust vectoring, it can make 90-degree turns shortly after launch. The AIM-9X can also lock onto its target after launch, allowing it to be fired from the internal weapons bay of the stealthy F-22 Raptor and F-35 Lightning II. Infrared energy is absorbed in the atmosphere, so longer-range dogfighting requires radar guidance. The main type is called semi-active homing. The attacker uses radar to paint the enemy. Some radiation bounces off the enemy and returns to the attacker. A radar-guided missile like the AIM-7 Sparrow senses this reflected energy. But with semi-active homing, the pilot must keep his radar pointed at the enemy until the missile hits. With his radar locked on the target, the pilot can't maneuver or engage other targets. The solution? Active radar homing, or the fire-and-forget missile. The AIM-120 AMRAAM can hit targets out of eyesight. Its active radar guides it to interception. The pilot can aim and fire several missiles at once at multiple bogies. Then maneuver to safety as the missiles guide themselves to their targets. For longer-range fighting, radar-guided missiles are the weapons of choice. Infrared-guided missiles are for shorter ranges, but modern fighters still carry a machine gun, typically a 20mm Gatling gun. A World War I fighter carried 2 machine guns and could fire about 800 rounds per minute. By World War II, fighters carried 6 or 8 guns and could fire 3,000 rounds per minute. The modern fighter's single gun fires 6,000 rounds per minute, 100 bullets every second.
The gun, employment-wise, we don't stray away from the gun. We don't de-emphasize the gun. It's critical to have it. There's a lot of times when missiles either don't function the way they should, and as you get closer into the threat aircraft, you have now become, put yourself inside the weapons envelopes of your 2 missiles. Therefore, all you have is a gun. Also, the gun is critical in giving you the opportunity to defend your way out of any fight, should you need to, if for some reason you get tied up with more aircraft than you were originally expected to see out there.
For nearly 50 years, pilots fought within sight of each other. Beyond a few thousand feet, the machine gun was ineffective. With the advent of radar and missiles, dogfights moved beyond visual range, with up to 30 miles or more between attacker and adversary. Air combat was forever changed. Modern fighters carry 3 types of dogfighting weapons: radar missiles for longer ranges, infrared-guided missiles for shorter range engagements, and a 20mm gun for close-in fighting. In pilot jargon, these weapons control 3 envelopes. The gun controls the sky up to a half a mile away. The heat-seeking missile controls an envelope up to 18 miles off. And radar-guided missiles control the long-range envelope. Enemies must breach 2 missile envelopes before a gun duel can take place. The first stage of a dogfight is called the initial merge, or initial point of attack. It's when the enemies spot each other on their radar. The first to do so has the crucial edge.
The important thing in using the radar is obviously to control the initial point of attack, and that's what the radar is designed to allow the pilot to do, to control that initial merge or the initial point of attack by shooting first or getting to a position where he can employ ordnance first, and that's what runs the war.
Modern fighters are designed around their radar. The airplane with a better radar identifies the enemy sooner and gets off the critical first shots. To preserve their stealth traits, the F-22 Raptor and F-35 Lightning II employ an advanced low-observable, electronically scanned radar array that can rapidly change the direction, power, and shape of its radar beam. It can acquire target data while minimizing the chance its radar signal is detected. At this stage of the dogfight, the enemy is just a blip. How can a pilot be sure that the blip is hostile? Airborne command posts like the E-3 Sentry or AWACS can help. Its radar scans for hundreds of miles, from the time the enemy fighters take off to first contact. Modern fighters are also fitted with IFF, or Identification Friend or Foe. This system projects a coded signal at other aircraft. The pilot transmits the IFF signal, and friendly aircraft return a coded signal. Even with the most modern IFF systems, there is still uncertainty. Until IFF systems are perfected, many pilots will hesitate to fire without visual identification. Then, the classic dogfight begins.
Turning hot north.
On World War I fighters, pilots aimed through a simple crosshair sight. By World War II, they used an optical sight. But missiles require something more sophisticated. In the late 1970s came the head-up display, or HUD. It's more than a gun sight. It's a wealth of information. During a dogfight, the pilot is no longer distracted by looking at his instruments. The data is projected right in front of him. The symbol in the center of the HUD shows the aircraft's attitude relative to the ground. The left bar tells the pilot his speed, and the right bar his altitude. In missile mode, the HUD tells the pilot which missiles are armed, their range to target, and time of impact. In gun mode, it shows how much ammunition is left and where to steer to hit the target. Even at visual range, a modern dogfight is far more complex than in the era of the Red Baron. But new fighters are designed to simplify the pilot's tasks. The objective? To put information and controls at his fingertips. To complement the HUD, modern fighters place many critical controls on the throttle and stick, called HOTAS. Having all the buttons and switches on the stick and throttle eliminates the need for the pilot to take his eyes off the horizon and the HUD. This improves a pilot's situational awareness and reduces reaction time.
The F-16 was designed to focus most of the pilot's attention forward and up and out of the cockpit, and those voice warnings for critical things such as fuel low or low altitude helps pull our head back into the cockpit to see what is causing the problem.
Despite technological advances, the modern dogfight has much in common with the classic dogfights of past wars. Once a pilot nears his enemy, the goals are the same. Spot him before he spots you. Protect your wingman. Maneuver to attack. Now, it's down to man, not machine.
The toughest thing is really the mental game. Once you are versed in pulling G's and can anticipate when you're going to need to pull the jet and then unload the jet, that becomes secondary. And the hard part is absorbing information from the radars, from the heads-up display, from your other flight mates over the radio, and then putting the picture together of what's going on in the fight, and then determining what course of action to take.
A World War I dogfight took place at 60 miles an hour. A modern dogfight, many times faster. Speed increases the strain on the pilot. A high-speed turn can subject his body to a crushing force, 9 times the Earth's gravity, or 9 Gs. This force can be so great, a pilot can lose control and black out. Modern fighters test the body's limits. The pilot must be in peak physical condition to survive. The performance of a modern fighter is stunning. So is its price tag. Typically between $20 and $100 million. In today's dollars, a World War I fighter would cost about $50,000. And a World War II fighter about $500,000. Size accounts for part of the increase. A World War I fighter weighed hardly half a ton. A World War II fighter about 5 tons. Today's fighters up to 25 tons. Since the advent of radars and jet engines in the 1950s, complexity has soared. A modern fighter is a complex weave of airframe, power plant, avionics, radar, and electronic warfare devices. Today's fighters aren't much larger than fighters from the 1960s, but their electronics are far more sophisticated. Electronics make up over 25% of a fighter's cost. In the late 1980s, the U.S. Air Force planned to buy 750 advanced tactical fighters, the plane that would become the F-22A Raptor. The number of planes ordered was slashed considerably. The airframe accounts for about half of the fighter's cost. Airframes cost more today because they must withstand more. The harsh conditions of supersonic flight and the crushing loads of high-speed turns. The plane's skin is subjected to extreme temperatures, the freezing cold of high-altitude flight, and the searing heat of air friction at lower altitudes. Aluminum has been the main ingredient in fighter planes, but today the recipe is more exotic. Rare metals, special lightweight alloys, and advanced composites are used to strengthen the airframe. The single most expensive item in a fighter jet is its jet engine. Few countries can manufacture fighter engines because key components are extremely hard to make, like the turbine blades. The blades must operate at temperatures of several thousand degrees and at high speeds without disintegrating. The new generation of engines has finally overcome the propulsion barrier. For the first time, their thrust is equal to or greater than the plane's weight. So the fighter can execute sustained vertical climbs and maneuvers with little or no loss of speed. The Raptor's engine also allows for thrust vectoring, making it highly maneuverable even below stall speeds. A pilot with such an engine can fly circles around an older fighter. Yet these engines are actually smaller and simpler than older engines with fewer working parts. The phenomenal climb and agility of modern fighters comes mainly from leaps in engine technology. The other expensive element of the fighter is its avionics, the name given to electronic systems: radar, radio, and navigation. Electronics account for about a quarter of the fighter's price. A single radar can cost more than $1 million. And fighter weapons aren't cheap. A heat-seeking missile like the AIM-9M Sidewinder costs more than $80,000. A long-range radar-guided missile can cost more than 4 times as much. Fighters are gas guzzlers, especially during takeoff or high-speed dashes when the afterburners kick in. Every hour in the air can burn thousands of dollars of fuel. The complexity of a modern fighter demands flawless maintenance. For every hour airborne, up to 50 hours of service. Such high costs keep the size of air fleets down. 40 years ago, an Air Force might have thousands of fighters. Now, just hundreds. But fighters can do things once unthinkable. Both the design and cost of the F-22A Raptor were controversial, but the Air Force stuck with it. It's built to blow anything else out of the sky. With record-breaking performers like the Russian MiG-29 Fulcrum and the Su-27 Flanker, the U.S. sought to regain air superiority. If enemy fighters gain dominance, they threaten everything else on the battlefield. Active radar missiles like the AMRAAM and its foreign counterparts are lethal. So the Raptor uses stealth to cloak itself. If an enemy fighter finds the F-22 at close range, a missile will have trouble locking onto it, thanks to the Raptor's anti-radar features. With new generation radar, the F-22 can detect enemy fighters at long range without giving away its presence. Result? A first look, first kill edge. In aerial combat, the first to fire a missile is usually the victor. Fighter pilots have always been a breed apart, now more than ever. If one feature distinguishes today's pilots from their predecessors, it's training. Air Forces invest a lot in their pilot candidates. It costs more than $1 million to train fighter pilots, and they fly multi-million-dollar pieces of hardware. To keep their skills sharp, they fly up to 200 hours a year. They must be intelligent enough to absorb their technical training and fit enough to withstand the enormous strains of maneuvering at supersonic speeds. They must have superior coordination and eyesight to survive a modern dogfight. This rare combination of skill and training makes fighter pilots the world's elite warriors.